This is presentation for DevOps special milestone. In the first milestone, our task was to set up configuration management and build environments for iTrust and Checkbox.io. We used AWS EC2 to run these applications. We created Ansible script to install dependencies like Nginx, Node, MongoDB for Checkbox.io. Similarly, we wrote Ansible scripts to install dependencies like Java, Maven, MySQL for iTrust. For the second milestone, we had to create a Jenkins build server that builds both the Checkbox.io and iTrust applications along with static analysis and testing. We did random testing of fuzzing on iTrust where we had to run 100 builds using the fuzzer. We wrote fuzzer in Python which randomly picks up a Java source file and changes one of the strings to a random string and then the whole test suite is run. With each build, both passing and failing test cases are recorded. At end of test marathon, useless detector is executed to find the always passing test. We also recorded the cases which were failing. For checkbox.io, we created a static analyzer that detects the max conditions in an if statement, detects method with more than 100 lines, and detects method with time complexity more than O of n to the power 3. Four jobs were created to achieve this task. The three tasks runs continuously in a cycle until it reaches a failure state where the number of builds are completed. For the first task, it runs the fuzzer and commits the code. For the second task, it runs all the ambient tests and reports the Jacoco coverage. For the post iTrust task, does a JIT reset, so it sets the source code to its original and accumulates the test results for useless test detection. The whole Jenkins server was set up using the Ansible playbook. For the milestone 3, we have used AWS EC2 instances for deploying Checkbox 7 iTrust and also for Jenkins as the integration server. We have used JIT Jenkins service to trigger the build jobs after the JIT push. If the build fails, it sends an email, otherwise, it triggers a deploy job which creates a new EC2 instance and runs the Ansible script on the newly spun instance. For the infrastructure upgrade, we have implemented a load balancer which directs the incoming traffic to the server in round robin fashion. The list of all the active servers is stored in the Redis list. We implemented feature flags and tested those on a new endpoint in checkbox.io. Whenever master feature flag is changed, it propagates to all the slave nodes and features are enabled, disabled accordingly. For the canary release, the load balancer initially directs traffic to all the four running instances. Then a new canary server is released, which is monitored for stability. A threshold value is maintained such that when the number of errors reaches this value, the instance is popped out of the load balancer and traffic is directed to the remaining servers as before. For the rolling update, we initially deployed iTrust to 5 EC2 instances. When we then introduce a code change which triggers the rolling update script which deploys a new WAR file to the existing instances one by one. While the update is being rolled to a given instance, the load balancer directs only traffic to all the remaining instances.